Hello and welcome back to Calculus 1, section 5.4, working with integrals. So we worked with limits, we worked with derivatives, now we're going to work with integrals, and then in Calc 2 you will be working with power series. You constantly work, it's mathematics, right? How do we work with integrals? Well, this is just a few formulas that will help your progress, I would say. The important formulas are obviously how to compute definite integral, and then that you can break it into few integrals at a number, which we did earlier. Now, the two formulas which I'm going to show first are convenience formulas. So, if you know them and you recognize the situation where they apply, you can cut out some calculations, which down the line, when you take Fourier series, will cut out a page of calculations. Right now, at this basic math level, you guys will occasionally use them. They will cut out some calculations in differential equations, but it's not as significant and crazy. These formulas have to do with even and odd functions that are being integrated. But before we jump into the formulas, I'm just going to say that the even function has the property like this. So example for this would be x squared plus 8, let's say. X squared plus 8 is the even function, and you can actually check that by computing f of negative x, which would be negative x squared plus 8, which works out to be x squared plus 8, which is f of x. So we have that f of negative x is the same as f of x, which means that the function that we put through the system was even. Cosine is the even function. Secant as 1 over cosine is even function. 1 over x squared is even function. There are a lot of even functions out there. And then there's odd function. You learned this in pre-calculus. There's odd function. An odd function has the property that this minus sign goes in front of the function. Let's say f of x is equal to x cubed minus 4x. So this would be odd function, and you can see that because if you are to calculate how much is f of negative x, you would have negative x cubed minus 4 negative x, and then when you compute this, you get negative x cubed plus 4x, and then when you factor out negative, both signs change, and you get your original function back with the negative in front. Just going to move this a little bit so I can fit everything here. So that means that this particular function was odd. Sine is odd function. Tangent is odd function. 1 over x is odd function. So there are a whole bunch of odd functions. And they all follow this property, right? And then you have functions that are not odd, are not even, neither, right? So e to the x, or ln x, or square root of x. So those functions are not even, they're not odd. So you have also that situation. So these two formulas that I'm writing right now are when functions are either even or odd. So if f of x is even, integral from negative a to a of f of x dx is the same as 2 times integral from 0 to a of f of x dx. So you still have to calculate the entire integral, but plugging in limits, it's easier to compute with 0 than to compute with negative number, right? Negative a. So it's a convenience formula that we use to compute these ones. The proof for this is very easy. We sometimes put that on the exams for honors sections. The second one is if f of x is odd. Again, symmetric interval. You will always get 0. So to illustrate this, let's say you have integral from negative pi to pi sine x dx. What kind of function is sine? It's odd. Now you have to memorize that from pre-calc 2. So sine is odd function. Odd function on the symmetric interval gives us 0. Let's prove that. So I have integral of sine is negative cosine x, computed from negative pi to pi. We have negative cosine of pi minus and then plus cosine of negative pi. Cosine of pi is negative 1, so negative negative 1, plus and cosine of negative pi, well, this is even function, so it's the same thing as negative 1. And you have 1 minus 1, which is 0, which you can immediately get if you know the formula above. You can just write equals to 0. You don't have to go through all these calculations. So these are convenience formulas, and if you don't know them, you will be doing the work in black that I have for the example. If you know the formula, you will just go negative pi to pi sine x dx equals 0, and you're done, because you know the formula, you know the theorem that helps you to that. Very few examples. You're going to run into very few situations like this in your calculus 1, 2, and 3. You are going to run into some of these more often in the differential equations, but that's, down the line in math, they're going to show up much more frequent. The one that we are, so the third formula and the last formula that we are focusing on is the formula for average. Average value of the function. That's the one that you absolutely must know. So average value of the function, the formula is f with a bar on top, is 1 over b minus a integral ab f of x dx. So this formula calculates the average value of the function. That's somewhere in the book. I don't know exactly which page. 379. 379, yes. So it calculates the average value. What it does is it smooths out the function. It has a lot of application, and anytime you're looking for the average value, you will be using this particular integral. So let's see an example of this. Maybe 2 examples, and then we're done. That's it. I hope you're not disappointed. So find the average value. Let's go with problem 24, because I know how much you love trig. f of x is cosine 2x, and the interval is negative pi over 4, positive pi over 4. Do we all have the same setup? All right, keep computing. So when we are computing this, we have 1 over pi over 2, right? 1 over pi over 2. And what do we know here? Even function on the symmetric interval means we can use the trick from before. 2 times 0 to pi over 4 of cosine 2x dx. What is the integral of a cosine?
Negative a sine of x.
The integral of a cosine is Positive sign. And yes, over A. So pi over 2 will become 2 over pi. Ugh. Yeah, I know, but when it starts doing this, it goes 5 times, goes crazy.
Is the stream still on?
Yeah, this has nothing to do with the stream. It's just that whatever is happening with the program, with the Windows 10, my Windows 8 never crashed. Not single one time crashed on the OneNote. And this is crashing since I got Surface 4 with Windows 10. It's constantly crashing OneNote on it. It's really annoying.
Wait, what happens when you debug it?
I lose everything that I...
Okay.
Yeah. He asked me to clear the cache, which erases everything I did.
Are there any like updates for that app?
I tried updating and verifying Microsoft files and doing all of that stuff, and it's just, when it starts crashing, it just keeps crashing when I start writing. So I have to restart the whole computer, which kills the stream, and then I have to restart the stream. This is a very short lecture, so I don't want to restart the stream because we really need another 5 minutes and lecture is done, and this keeps crashing now. See? If I delete the notebook cache, that will delete everything that I did. So I'll try one more time. Yeah. Well, that kills the stream. Basically, the answer for this, I'll just post this in lines then, and you can compute this. We'll do one more example. I just have to restart the whole computer for this.
To make sure we get it right, it's 4 over pi over 2.
Yeah, let me restart because